All right, so there we go. Our recording is rolling and we have our home screen up, and let me show you guys what I've been busy working on. And to do that, I'm going to engage my student view. And now I'm going to go to modules. So I've been busy building this week 7 module, which is all about brakes and braking systems. This is something that, hey, if you're taking somebody else's AT100 course that's online, they didn't have this in there. But what really bothered me is that this was part of the AT100 class, traditionally a very basic brake section, right? We're not going to cover everything there is to know about brakes, but I know that you guys, as either budding automotive professionals or just a person who wants to be a do-it-yourselfer, everybody's going to do brake service on their vehicles, I figure. And so we do need to cover some stuff. So I've been busy working to get you guys some brake information. So going down week 1, 2, 3, past week 4, I can't stress enough, by the way, how important vehicle inspections are, right? Remember, that's where we find and identify problems and recommend services that can not only make us money as a professional, but can help keep our customers' vehicle running or your own vehicle running better, right? Hey, one thing to note on those inspections, like if you're doing one of your inspection sheets, make lots of comments, okay? Don't just say, oh, everything's good or everything's bad. It's all about the comments and the details that really let the customer know what's wrong with their car and that really sell that job and bring it home, and that keep us legal with the Bureau of Automotive Repair if you happen to be doing this at a real automotive shop. So good detailed comments are what is needed on those inspection sheets. So for some of you guys, I made comments on your sheets and I said, hey, my comment to you was to give me more details on your inspections, okay? Of course, tires and wheels, super important on those tires. That's the only thing connecting us to the pavement, right? So we're talking about brakes tonight, but I don't care how good of brake pads we have. We could have the best brake pads in the world, right? If we have really lousy tires, that's not going to do us any good. So again, we need to have good tires on our vehicle. With that, normally we would have had you guys installing tires on vehicles in this class, right? And that's not something that we can do. You guys certainly, if you feel comfortable, you could rotate your tires at home, right? And we talked about different rotation patterns last week. That would be a good thing to do. We talked about using a penny to do a tire tread depth inspection, how to read your tires and check their air pressures. Anyways, what I do want to do before we jump into our brake section this week 7, which is what I've been working on here, is take a sidestep and let's look at the summer schedule, because I think it just launched for the college. So I'm going to tab over real quick. Here we are. Of course, you guys go here to log into Canvas each week and do all your activities, but we're going to see what's going on with that schedule. So, why can I never find the scheduled college catalog? Oh, no, that's right. It's at the bottom. Apply, request, enroll. No. Where? Missions, academics. I don't understand why there's not just, oh, there it is. Search class schedules. I don't know if I'm missing it, guys, but I don't know why that's not just like the biggest button right there. Like, what's the upcoming class schedule? I always am hunting around for it. I don't know if I'm missing it. You guys tell me, but whew, I tell you, I always feel like I have to hunt around for that thing. So, summer 2021. All right, subject, automotive. Where is it? There it is. Just a couple things here. We have an auto collision program as part of ARC off campus. AMT, Automotive Mechanics Tech, that is our sister program at Cosumnes River College. Okay, so that's CRC. This one, AT, is ARC. So you can see we have a couple 18100s running. They're going to be online. I'm still kind of going through my rosters to pick the right instructor for those courses. So pretty soon you'll have a teacher's name built to that. But what I wanted to point out to you guys is some of our other classes. For instance, you see my name here. I'm going to be teaching a AT140 class, which is called the Skill and Speed Development. But the idea is after you've had some other classes, it gives you extra hands-on time. Well, for us, it's going to be just hands-on time period. So if you guys are in this class and you're really chomping at the bit, you're like, man, I really want to do some hands-on work, one of your options would be to jump into AT140. Okay, and I'm going to run one of these in the summer. I'll run one in the fall. I'll try to run one next summer. I'll just keep them running over and over and over again as a way to give you guys more hands-on time. Now it says lecture mode in person, lab mode in person. This thing is actually listed a little bit weird, asynchronous, no meeting. Here's what we're really doing. And the school had a really hard time getting this scheduled correctly, and it still looks messed up. And this is why I wanted to go over it with you guys. What we're going to do is there's 16 spots in this class, 16 seats, which is less than what we normally have. But we're going to take those 16 students in the class, we're going to divide them up into two groups, an A group and a B group, okay? And so the class is supposed to be like Tuesdays and Thursdays. Let's see if I can find the days here. Why does that not say? So AT100, you guys are in it, you got it. Details, okay, yeah, Tuesday and Thursdays from 9:30 to 3. But basically, let's say you're in group A, you only come on Tuesdays. If you're in group B, you only come on Thursdays, okay? You're gonna come to school one day a week and you're gonna have like lab pretty much the whole day. I might start with a little demonstration of a particular machine, like the tire machine, for instance, or something. And then you guys are gonna get to work on stuff and do things. You could do a lot of the hands-on labs that we didn't get to do hands-on as much in this class. You could do projects and stuff. Now, it can't be like rip your engine apart, but projects that you can realistically get done in one day. Well, what about the lecture for that class? Well, that class is all about skill and speed. So I'm going to be sharing a lot of tech tips and different things, and I'll put those online through Canvas. Okay. So with that, that's how that AT140 class is going to work. And that will be a great one for you to try to get into this summer or perhaps next fall to kind of make up for some of the hands-on stuff we're not doing right now. Okay. I don't know why this says TBA for AT301, because that's also supposed to be my class. Anyways, this class is going to be online, but what I'm going to set up kind of outside of the school is some meeting times on Fridays to help you guys with technical issues for that small engine class. That's a great class. We're going to have an air conditioning class, engine performance. That's kind of more of an advanced one, and the smog's more of an advanced one. You guys might really be interested in like taking the heating and air conditioning. Why? Hey, it's summertime. This is a good money maker of stuff to get into. AT140 and AT301, those would be 3 good classes for you guys to get into. All right. I wish we could offer more. This is kind of our first offerings of in-person learning, and it took a lot of, let's say, complicated negotiations to make this happen. So hopefully you guys are excited about it as I am, and maybe I'll see you there this summer. We're going to have a good summer. It's going to be good to be back in the shop and get things rolling again. So fear not, anything that we're not getting to do as well as you would like, or as well as I would like, through online right now, our AT140 class, you can take that class like 4 times and get yourself lots of hands-on time. Okay. And I've taught, I'm an ASE Master Certified Tech. I've taught all kinds of classes, done all kinds of work. So there's pretty much nothing in the shop that I don't know how to do. And if you have a project or questions on something, I should be able to help get you going in the right direction. And that's why I'm the one doing this 140 class. So that's this summer. I guess we better get back to the spring though. And we're here on week 7 talking about brakes. Now, this is the one where I've been in charge of this section, adding it to our list of things to do and information. And I got some handouts for you. These are right out of the AT100 book. A little bit about brakes, different types, the brake linings, the fluids, good stuff to know. So I want you to review that, or expect you to review that. This presentation here is what we're going to get into tonight. And so if you want to go back over that, of course you can. So there's our brakes guy there. And then I have a couple of website links. A lot of times when we're doing disc brakes, right, there's a lot of complaints these days with brake noise. So, if you read a brake package, they'll talk about noise levels and all kinds of stuff. And so this is a website link, and I don't know why it's not working, but I'll click it and it'll take us there. That's talking about brake noise. Now, the automotive term for brake noise is NVH, for noise, vibration, and harshness. And it really comes down to friction materials. Do any of you guys know why brakes these days tend to be noisier than they were years ago? Or is this something you've heard about? Or how about this? Let's make it even simpler. Give me like a thumbs up, or raise your hand on the reactions tab on Zoom if you've had a car with squeaky brakes. Anybody had that before? You've been in a car that made all kinds of brake noise. Okay, Caitlin has, right on. Okay, Tyler, yeah. So I'm probably older than most of you guys, and I can tell you in my years of service, I saw brake noise really become an issue in the 1990s. And the reason is because in the late 80s, early 90s, we started phasing out asbestos from brake lining materials, in that the friction material that rubs on the surface of the rotor used to have asbestos in it, and asbestos made a great material. It had good wear characteristics, but it also had high heat resistance and low noise. Well, the problem with asbestos is when it gets ground up into a fine dust, and if it gets airborne and you breathe it, it hooks into your lungs and leads to lung cancer and all kinds of nasty things, guys. So you really don't want to be breathing asbestos. And that's why maybe some of you guys were in school and they were maybe remodeling your elementary school and replacing the paneling on the walls and stuff. And if you asked, you said, well, what's going on? Oh, they're updating the school to remove all the asbestos materials. asbestos was a real common brake material, but it also was a common material used in like insulation because it absorbed heat, all that type of stuff. So anyways, we had to get rid of the asbestos and replace it with other things. And we replaced it with stuff like metallic compounds, right? You might have heard of semi-metallic pads and Kevlar and all kinds of different materials to try to find a replacement for asbestos. A lot of the brake pads that are give you more stopping power, more stopping grip, if you will, more friction, they tend to be noisier. They also tend to make more brake dust as well. So it's kind of a trade-off. Do I want a brake pad, a brake material with a lot of stopping power? Do I want a brake material that is nice and quiet and doesn't make a lot of brake dust? It usually is not going to have the stopping power that you would have with something else. And it's also not going to have the lifespan. So sometimes you're shopping for brakes and they'll say, oh, these are organic pads and these are metallic pads. The metallic pads are going to make more noise. They're also likely to last longer. Okay. Ceramics are very popular these days. Ceramic pads usually make less noise and are lower dusting, but again, they don't tend to give you that ultimate stopping power that you would have from a high carbon friction metallic or something. Okay, so it's really you have a lot of choices when it comes to brake pads. I will say that 9 times out of 10, the brake pads that come on your car from the factory, like the dealership, like if you have a Honda Accord, right? The brake pads that you would buy from Honda that are like Honda brand brake pads, those are going to be the quietest pads, right? Because the car manufacturers, they don't want to sell somebody a car that has a bunch of brake squeal and brake noise. They know that that's not going to make a happy customer. So they tend to engineer a brake material that's going to be nice and quiet in its operation. Okay, may not necessarily be low dusting, but it's typically going to be a quiet material. So if that's your goal, it's hard to beat dealer pads. If your goals are more stopping power, maybe you're going with the aftermarket company like Hawk or HBC or EBC, I mean, or something else, performance friction, something like that. If you're going quality aftermarket, maybe you're after Raybestos or something. So I have an article here all about brake noise and how to deal with brake noise and why it's something that we deal with these days. So that's a good one for you to review. If I go back on here, I have another web link here about common brake pad questions. But let's jump into the assignment. It's just like we've been doing. I have several videos here. These ones are theory related. This is one that I pieced together here, doing brakes on my Miata here. We have our brake inspection lab sheet that should be fillable. Let's see if this link works. And I should be able to download it and fill it out. Let's see if that will work. Okay, and so if I download this thing, I should then be able to click the different sections. Okay, so just like we've been doing, let's go back. And then ultimately we have our week 7 quiz, which is a little 5-question quiz based on the stuff that we're talking about right now, and based off your resources and the handouts and stuff, right? So that's what we have due on brakes. Remember to use your course calendar here to see what's up, because our lectures are usually like a week or 2 ahead of what's due, to give you guys time, especially students that can't be with us live on Zoom on Tuesday nights, gives them a chance to get stuff done. So here we are on the 9th. We do have some stuff coming up. I think I'll move this midterm back, and because it looks like a few things are messed up. Like, why is quiz 6 not in there? Looks like we have some stuff to fix here, because this is not what it was supposed to be. So the brakes material won't be due this week. We're going to push that off to next week, so everybody has a chance to review the videos and get their stuff in a row. And this is it's a good thing that I did this, looked at this in my student mode. For whatever reason, oftentimes in my teacher login, everything looks perfectly set up. And then when I have it under student mode is when I see that there's some issues. Then I have some times where even on student mode, it looks perfect, but you guys, when you look at it, something's not right. And so that's why it's so important for you guys to let me know if something's not working right. Several of you guys reported about the tires being locked, and I think I got that all fixed from last week. Sometimes Canvas can be just a little bit clunky on there, or sometimes I didn't check the right box or something. So we're making the best of it. So this is where you go to see what's due. All the stuff we're talking about tonight will not be due till next Friday. And then after that, we'll do the midterm, because our class topic for next week is getting you guys prepped for the midterm. Okay. All right. So let's go back. Let's go back to our course and back to that week 7 module. And we're going to jump into that brakes presentation. Okay. And I always like to scroll through this because so far, basically, we've gone through tires, under car inspections, above the car inspections, if you will, or under hood inspections. We've talked about hand and power tools, a little bit about chemicals and stuff with MSDS information, lots of safety stuff, and of course, giving you guys an overview and a little bit about getting to know your car, right? Those are the things that we've done so far in class, okay? All right, so I'm gonna change my screen share, and we are gonna jump into our brakes presentation. And remember, if you guys have questions on stuff, make sure that you ask me, right? Like, don't, I don't just assume I know what your question is. You can always put it in the chat if you want to do that. But make sure if you have questions, right, I'm here to answer those. So I'm going to change this screen share a little bit. And that should make it show up a little bit clearer on your screen. And we have our brakes buddy there. And hopefully that's not how you're stopping your car, right? With flintstoning your feet underneath the bottom of the car. All right, so brakes are, next to tires, brakes are like most important system on the car, right? I'd rather be able to whoa than go, and that if I can't get this thing stopped, I have a really dangerous vehicle on my hands. And I've been repeatedly surprised or horrified, if you will, of how bad the brakes are on some people's cars that they're driving around there, right? And they got rotors worn through to the nubs, metal to metal on pads. I have seen some absolutely scary stuff. All right. So first we're going to talk about the brake fluid. This is like the blood of your braking system, right? Our brakes on our vehicles going back the last, 80 years are hydraulic brakes, meaning that when we step on the brake pedal, we move brake fluid through the system, and it's the fluid that transfers the pressure from our foot to each caliper and wheel cylinder, basically like each brake assembly at each wheel, to stop the car. Really, really old cars, right? Like Model Ts and stuff, they might have had mechanical brakes that were moving like levers and cables. But once you got into the 1930s and 40s, we went to hydraulic brakes. And so the brake fluid that's in our vehicle is super important. It's so important that it's rated by the Department of Transportation. So when you see this and it says DOT, you might have seen the words DOT like on a motorcycle helmet. It's Department of Transportation. They're rating the different brake fluids. So you can see that this bottle right here is .3 brake fluid. And so there's .3, there's .4, there's .5, there's a .5.1, and heck, there might even be some other ratings beyond that. The typical minimum standard for our passenger cars and light duty trucks is going to be .3. Okay. If I have a performance car that maybe, you know, is made to go out and do track days and different things, maybe I bought a BMW or a, you know, a new Miata or something, they might specify a .4 fluid. Okay. .5 is a kind of a weird deal. In fact, I'm going to circle him with kind of a pinkish purple there. The reason is .5 fluid is a silicone, actually a silicone-based fluid. And the advantage of it is that it doesn't absorb the moisture like the typical .3s and .4s, but silicone is squeezy. And so it doesn't, you know, it's compressible. Doesn't give you the same brake feel, but a lot of guys with like classic cars and some specialty applications might run a .5 silicone, I'm sorry, based fluid. Okay. Now, .5.1, this is again going to be a glycol-based fluid that's even higher temperature. So one thing about these going from, and I'm going to put a 3 over here, from .3 to .4 to .5 is we're going up a scale of temperature. Okay. So .4 can handle more temp than .3 can. .5 can go even hotter. .5.1, you know, in theory can go hotter. These fluids, 3 and 4 and the 5.1, are going to be hydroscopic fluids. And that means that they absorb moisture or water out of the air, out of the system. So one thing about brake fluid is that we really want to change this out of our vehicle every 2 years. Why 2 years? Because it's hydroscopic, man, and it's always getting moisture saturated. It's always sucking water, even if it's all sealed and the cap's on, all that stuff. It's always sucking water out of the air. And as it absorbs more moisture, its boiling point goes down. Okay. If you think about your brake system, what you're doing is the car might be going, you know, at a high rate of speed down the road, right? So you got the car, he's hauling down the road here. Well, we're going to take all that speed and all that energy of the car going maybe 40, 50, 60, 70 miles an hour down the road. And here's my car right here. Let's say I got a goat cart, but I'm hauling down the road. I hit the brakes. I'm going to take that energy, that kinetic energy of going 70 miles an hour, and I got to convert that energy into something. I convert it into heat by friction, by the brake pads squeezing the rotors, by the brake shoes squeezing the brake drums. So I take all that kinetic energy through friction, it gets converted into heat energy. And one thing you'll see is that your brakes get really, really, really hot. In fact, if you went and drove your car around and you just touched the wheels, you would notice, oh man, the wheels themselves are hot, because all that brake heat will then radiate out into the wheel rim and everything else, and to the tires too. And well, that heat also transfers into the brake fluid. And if your brake fluid gets too hot, the danger is that the brake fluid could boil inside your brake lines. So we don't want this fluid to boil. So it's supposed to be rated to really, really high temperatures, okay? But as it gets more saturated with moisture, what do you guys think its boiling point does? It goes down, right? So the longer you go between brake fluid changes or flushes, the lower the boiling point of your fluid is, and that could lead to a brake fade issue. So typically speaking, I don't care if we've gone 20,000 miles or 2,000 miles. What we really want to do is change our brake fluid out of there, get all the old fluid out and fresh fluid in, and do that every couple of years. And if we do that, what we're going to find is we're going to have less problems with the hydraulic systems on our brakes. We're going to have better, more consistent brake pedal feel, and we're going to have less problems overall with our vehicle. It's going to be a safer thing all the way around, okay? So most manufacturers recommend every couple of years changing that fluid out of there. All right. So then if the brake fluid is like the blood, right? The master cylinder really is your heart of the brake system. In that when I step on the brake pedal, when I step on the brake pedal here with my foot, through that pedal, right, it moves some linkage and it pushes a piston in on the master cylinder. Now the master cylinder then is like a pump, right? It then forces the fluid to the rear wheels, and it also forces brake fluid to the front wheels. So like I said a minute ago, he is the heart of your brake system. Now, the ratio of the size of the master cylinder piston and the size of the pistons in the front brake calipers and rear wheel cylinders, that's a big deal because the size of those things controls how much we can either multiply the pressure of our foot or keep the pressure the same or make it go down. There's a whole formula to figure this out, and we can manipulate things, basically multiply the amount of pressure that we're pressing on with our foot. We can make that many times stronger by using this hydraulic system. It's the force area pressure formula, more easily shown with a little pie chart here. F for force, A for area, and P for pressure. And I can put all these guys in a handy dandy pie chart. And if I want to know one, all I got to do is I got to know two of them and I can figure out the other one. So if I pressed on the brake pedal with 100 pounds of force, right, and I had a 1-inch area, you know, I can then calculate what the pressure is going to be in the lines. And then once I know the pressure, I can go back to the force that's applying on the brake pads themselves. So basically, the engineers who build and design our cars use this formula to figure out how much brake force do we want squeezing the brake pads in the front and squeezing the whatever brake system we have in the back, whether it's discs or drums, squeezing those rear brakes as well, okay? This isn't something we typically change as a typical mechanic, but it's in there behind the scenes to give that vehicle the right braking feel that they were after. So these brakes are hydraulic. The heart of the system, though, is the master cylinder. So one thing I will say is, hey, if the master cylinder fails, guess what? You're going to lose your brakes. You're going to lose your ability to stop the car, okay? Likewise, maybe you've seen movies or shows on TV, somebody cuts one of the brake lines. They cut a brake line and the brake fluid then spills out, okay? You're not going to have any brakes because if I can't maintain the pressure, if the fluid just leaks out on the ground, boom, I'm not going to have any brakes. So I'm going to be hurting for certain again. Lastly, what we were talking about a minute ago, this system is hydraulic, and hydraulics work off of the physical property of that you can't compress a liquid, right? We can compress air, right? But we cannot compress a liquid. Well, guess what? Let's say the brake fluid hasn't been changed in a zillion years. It gets so hot, it begins to boil in the front brake calipers. That is going to put a whole bunch of air bubbles in the system. And now you're going to step your foot. It's going to go to the floor, and all it's going to do is compress that air. And it's going to give you a real soft, spongy brake feel, and the car's not going to want to stop. And we call that brake fade. So again, why do I want to change my brake fluid out of there every couple of years? Well, if I don't, I could end up where I'm in a brake fade issue due to the brake fluid boiling inside the brake calipers and lines and stuff, okay? All that would be bad. All that, you'd be looking for a runaway trunk ramp or something, or you'd be crashed into somebody or something, okay? So the brake fluid is super important. The master cylinder is super important. Let's take a closer look at how that master cylinder works. So inside the master cylinder, that's where we add to the brake fluid level of the vehicle. So here, I'm going to highlight this in blue. We have our top part is our master cylinder reservoir. Here's a plastic reservoir. These are a lot more common these days because you can see through them and see what the brake fluid level is. So that's where we add our .3 or .4 fluid to the vehicle. But underneath this reservoir is the pistons and stuff. So those pistons are what actually move the fluid through the system, and those pistons get moved when we step on the brake pedal. Now, all vehicles since the late 60s have a tandem master cylinder that might be longitudinally split, front to rear, or diagonally split. But the idea is that we make the front brakes and rear brakes, we build them as two separate circuits. So if one circuit were to fail, hopefully the other circuit would keep going. It makes the car a little bit safer. So let's say this rear piston failed. Maybe I would just lose my rear brakes, but I wouldn't lose my front brakes. So I might be down to 50% of my overall braking, but I would still have some braking left in the vehicle. That's the idea of a tandem master cylinder. And like I said, late 60s, 1968, I believe, is when we started putting those on our car. It was one of those Department of Transportation requirements, one of those federal standards. Here's another shot of another style of master cylinder. Again, reservoir on the top. That's where you put the brake fluid in. Then you have a couple of pistons. You have some springs and stuff in there. Again, when a master cylinder fails, it's almost similar to when you have a hole in the brake line or something. It's like it's not pumping the fluid and you lose that brake pedal feel. You might have a brake pedal that goes to the floor. You might have a brake pedal that slowly sinks to the floor, okay? So how can I pick up when a brake master cylinder is just starting to fail? Here's one of your little tech tips for tonight, and I have a lot of them. Like our first one was change that brake fluid every 2 years, right? And then about brake noise. So here's, I guess, brake tech tip number 3. There's little tiny rubber seals in here. I'm gonna show, okay, well, here's a seal, here's one seal's here, here's another seal right there. So let me redraw these brake seals. So here is the piston, and it's going in the bore, and I'm going to draw this in brown. Here is the little brake seal, and it's a lip seal. So it's designed kind of like this. So when you step on it, it kind of flares out and does a better job sealing. Well, when this lip seal gets all kind of hard and it's getting worn, brake fluid could, just leak by past it, and the brake pedal will slowly seal the floor. But if I jammed on my brake pedal really hard and really fast, it would move that seal so fast he would kind of flare out and grab the walls better. So if you have if you slam on the brakes and it seems like they work, and everything's good there, but if you are, let's say you're sitting at a stoplight and you have your brake resting on your brake, you have your foot resting on the brake pedal, just kind of lightly to keep the car from creeping forward at that stoplight. And if under that light pedal pressure condition, you notice the brake pedal just kind of starting to slowly sink down, that's a sign that the fluid is bypassing the seals and that your master cylinder is starting to wear out and should be replaced. Okay. So if you have a slow pedal sink that works if you jam on them hard, that's a sign of your master cylinder just starting to fail. And it will usually go through that routine for a few weeks, and then it will just fail altogether, and you'll go to stop, and all of a sudden it's like you got no brakes. So you want to try to catch it early. Okay. So what I would do with my customer's car, if I had it in for an inspection, typically any inspection, but especially on a brake inspection, is one of the things I would do is I would just sit in the car for a minute and put my foot on the brake pedal, and I wouldn't be jamming on the brakes. I'd only just let kind of like the weight of my leg, the weight of my foot just resting on there. And I would see, does the pedal slowly sink down at all? If it does, I'm going to recommend master cylinder replacement. Okay. We'll keep moving it forward. Okay. So we know our brakes are hydraulic. However, most cars these days, and this is going back to the 1970s, not only are they hydraulic brakes, but we have power brakes. Now, most vehicles will use a vacuum power brake booster, and that they'll use vacuum from the engine to help you get more brake pressure in the system. A few cars, like my pickup truck, happen to use a hydro boost. They use pressure from the power steering pump to boost our pressure from our foot to give us more brake pressure ultimately to our wheels. Let's check those things out. Here is a vacuum booster. What is the actual vacuum booster part? Well, this weird looking silver thing back here, that is a huge diaphragm, and you see that here's a vacuum hose going to it, and that goes over to the engine. This is our vacuum power brake booster. Okay. What's this rusty looking thing right here? This is the old school style master cylinder on this particular vehicle. Okay. So this has power brakes and it uses a power vacuum booster. Okay. If you were to disconnect that vacuum hose, what you would find is the car would still stop, but it would be really, really hard to stop, in that it would require significantly more pedal pressure from your foot pressing on the brake pedal to get the car to stop. All of a sudden it'd go from braking like a modern car to braking like a 1930s pickup truck or something. It would take just a lot of pressure pushing on the brakes to get it to stop. Okay. Okay. Moving right along. The other format would be hydro boost. And this is what I have in my pickup truck, where we have a couple of power steering lines coming over from the power steering pump. They pump to this weird assembly here, which basically multiplies the pressure of our foot. And like right now, like on my truck, this assembly happens to be leaking power steering fluid like a sieve, So I got to keep topping off the fluid because I need to change this thing out of there. And they're not cheap. And quite frankly, I just haven't had the time to do it. So anyways, that's Hydro Boost. You see it used on pickup trucks. Diesel engines will use it because they don't make manifold vacuum like a gasoline engine would. Some heavy duty applications, but most vehicles that have power brakes will use a vacuum power booster that looks like this. Now it might be painted black, it could be painted silver, it could be just metal colored like this one is, but it's a big diaphragm looking thing that sits behind the master cylinder. Okay. Now we're getting to the brakes themselves, right? We know we have disc brakes and we have drum brakes, right, guys? Disc brakes and drum brakes. If you were going to do brakes on a car, what I would recommend is do disc brakes first. Disc brakes are easier to deal with. They don't require typically a lot of special tools. All in all, it's a less frustrating experience doing disc brakes versus doing servicing drum brakes. Okay. So disc brakes, I have here disc brakes that they work the same way as your brakes on a bicycle, where your bicycle brakes squeeze your rim of your bike to slow it down. These squeeze the surface of the rotor, right? You can see the rotor sits right underneath your wheels. So it's connected to your wheels and it bolts onto the hub. And if I stop the rotor by squeezing it with the brake pads, it's going to stop the car, okay? Every time the car is going down the road, every time the wheel is rotating, of course, the rotor in here is rotating. And you notice that this rotor has fins on it, so it helps for cooling. One thing that disc brakes do a lot better than drum brakes is they cool a lot better. Okay, I think they have several advantages. Disc brakes are self-cleaning in that the brake pads are always wiping across the surface of the rotor, so that helps keep their assemblies clean. They're better cooling because air can contact both sides of the rotor. The rotor can move air through the inside of itself. And both of those things, and they're also self-adjusting. And so all three of those things really promote a better brake system that's easier to service and ultimately can have more braking power because it has better cooling. So here's another shot of that system, and we'll clear out some of my scribbles. So most factory vehicles, most production cars for passenger cars, light duty trucks, they're going to be single piston calipers. Why? Well, it's cheaper to build, it's cheaper to make, it's in theory might save a little weight on the brake assembly. So the idea is that when we step on the brake pedal, right, we are moving brake fluid through the line. The brake fluid comes up and it pushes on the piston. And I'm sure you guys have heard in school, right, in your physics class, for every action, there's an equal and opposite reaction. So the brake piston squeezes that brake pad against the surface of the rotor, which then the opposite reaction is this whole assembly then wants to move. This whole brake caliper assembly wants to move that way. And when it does, it forces that pad, the outer pad, against the surface of the rotor on the other side. So what that means is not only does the piston have to be able to move back and forth, but the whole caliper has to slide back and forth. And so this style of caliper is commonly going to be called a sliding. I'll just type this in. This will be called a, let's make it something brighter here. a sliding or a floating caliper design, because I only have a piston on one side. Now I could have two pistons, but if all the pistons are only on one side, the pistons apply here, the caliper slides there. Both those things have to go like that together to get the brake pads to squeeze evenly on both sides of the rotor's surface, okay? And what will often happen is that either the piston will get stuck in its bore because people never changed the brake fluid and it got all corroded in there, or they never lubricated the caliper slides, and now the caliper gets applied and it sticks on there, and then it doesn't release properly. And either one will cause you to have brake pads that are not evenly worn. Okay. So there's another sliding caliper design. We can see the rotor, inboard pad, outboard pad. Rotors are typically made out of cast iron. There are some high performance cars and stuff these days that have carbon rotors. I was at the racetrack this last weekend and a guy blew out a tire and he's like, oh, I can't drive in on the flat tire. Why? Because he has a carbon fiber rim on that thing. That rim is like $4,000, he said. I don't know. Some people have maybe more money than common sense. But anyways, the most brake rotors are made out of cast iron, and you know, it's heavy, but it's a good friction surface material. Why would you have carbon rotors and all this crazy stuff? Carbon fiber is very light, and vehicles that would have stuff like that would have to run very high tech, special brake pads that's compatible with those rotors and everything else. All right. So solid versus vented rotors, right? A lot of times we might see solid rotors in the back of the car and vented rotors in the front. The idea with the vented rotors is it's going to give us more brake service or more brake cooling, which means that we could get more friction out of that assembly and have you know, more stopping power going on. There's another shot of the caliper piston. And again, this would be a floating or sliding caliper design here because it's only got one piston on that side. Okay. And we talked about how for every action, there's an equal and opposite reaction and how it squeezes the pads. Before we move to drum brakes and stuff, I need to show you my other type of caliper. And I am dropping the ball here. I thought, guys, I thought I had it on here, and I guess I don't. So I'm going to go back to the internet real quick. And you know what? I always like the Brembo brakes. We're going to look at a Brembo. Oh man, look at that. That's beautiful. I need some of those. Only $3,000. Now, this would be an example of a 4-piston fixed caliper design. Let me say that again. 4-piston fixed caliper. How do I get that from here? Well, why am I 4 pistons? Well, if you look at this, there's one piston there, another one over here, and another one over there. If I wanted to change the brake pads on this vehicle, what I would do is I'd pop out that little pin, I'd pop out that little pin, and these things would slide out of there. Almost like, you know, taking toast out of the toaster or something. You know, those brake pads would slide out and you could slide some new ones in once you depress the pistons back into the caliper. So this would be a fixed caliper design. Let's see what it looks like in black. Ooh, that looks good. That looks good. That would be hard to clean. All right. The idea is that it's fixed. We're going to have very even brake pressure from side to side. And of course, if I wanted even more pressure, maybe instead of a 4-piston caliper, I could have a 6-piston caliper. You get the idea, right? And so high performance cars are going to usually have some type of fixed caliper design, and it's going to have you know, 4 pistons or more to give you lots and lots of braking effort. Okay. Regular production cars are usually going to have a sliding or floating caliper design. So, like if you bought a Subaru, just the base model WRX, it's going to have sliding calipers, or technically they're floating calipers. They float on a couple of pins. But if you bought the STI model, it's going to have some cool looking Brembo, something like this, where it's 4 piston fixed caliper, gives you, you know, more braking capabilities from that vehicle. Okay. So fixed calipers versus our floating or sliding calipers. Most of your regular production cars, unless there's something high performance, they're going to have a floating or sliding caliper. Now, let me change my screen share back to our presentation. Let's get back to where we were. And we'll wrap this thing up here in just a little bit. So let's get back to where we were, and we'll make this thing a little bit bigger. I'll do this new share one more time. There we go. So I don't know. I think this is like tech tip of the night number 4. Okay. Most cars have these types of brakes where it's a floating or sliding caliper. The difference, calipers that slide are like the old Fords where there's V-ways cut into the caliper and caliper mounting brackets. Most cars float on a couple of pins. So if you watch my video of the Miata brake job, that's a floating caliper. It floats on a couple of pins. I make a big deal to talk about greasing up the caliper slide pins so that they float back and forth. Here you can see new brake pads, the piston's all the way back in there, and worn brake pads, the piston just automatically moves out and adjusts for that. That is why you have a little bit, maybe a little bit softer of a brake feel as the brake pads themselves wear. Okay. That's also why the brake fluid level in your master cylinder will drop down as the brake pads wear. So tech tip like number 4 of tonight, if your brake fluid level is low and you don't find any leaks in the brake system, it's probably a good indication that your brake pads themselves are worn. Because as the brake pads wear down, the pistons move out due to that wear, and it gets backfilled with extra fluid, and so the fluid in your reservoir drops. So I can look at my brake fluid level, and if somebody hasn't topped off the fluid level and I see that it's low, that's going to indicate to me how worn the brake pads are. Okay. Now, tech tip number 5 is, let's say I got 2 brake pads here, and let's say the outboard pad is really worn, but the inboard pad looks pretty good. He's not worn that much. So the outboard pad is really thin. He's worn down. The inboard pad looks pretty good. What's going on? Well, in that case, what's happening is the caliper is not allowed to float back and forth. It's getting stuck and it's not retracting, so that the outboard pad is always sticking. And what you need to do is take it apart, maybe get a new hardware kit, lube up the caliper slides really good, and that would fix your problem. If the inboard pad is worn down, so I'm going to make this one red, but the outboard pad is nice and thick, it doesn't look worn, then you would have the opposite. You would have a piston that's sticking in the caliper and dragging on the inside, wearing out the inboard pad, and the outboard pad wouldn't be worn. So that would be, you know, not only you want to replace the brake pads, but you want to replace that whole caliper. Okay. Okay. So moving right along, rear disc brakes are, you know, becoming more and more common, which is fantastic. But the challenge is this: your parking brake here. Okay, remember I said brakes are hydraulic, but guess what? Your parking brake, it can't be hydraulic. Okay. The parking brake has to be operated by means of some type of cable mechanism. Okay. So if I have disc brakes all the way around, I have to have some way to make a working parking brake. So for this particular one pictured here, this would be like an older Corvette, or they had a mini drum brake on the inside of the hat area of the rotor. And this drum brake was just for the parking brake only. Okay. Other designs, like on my Miata, will have a overly complicated a brake caliper that has like a little screw assembly in there that you got to deal with to have a mechanical parking brake. So parking brakes operate off of mechanical means, some type of levers and cables there. And that's why they usually don't work as well as the hydraulic brakes do. So anyways, that's one style of a parking brake mechanism on a disc brake vehicle, and that particular one uses a little drum. Kind of interesting. So when we look at our brake pads, if we got some fresh pads, we can get some good information about the linings. Like, see those F's there? That denotes the coefficient of friction, and the higher it goes in the alphabet, the more friction it has. And one letter is for cold operation, the other one is hot. So what this pad is saying is it's got the same amount of friction, both hot and cold, but not all pads do. Some pads might be like an EF or a FG or what, anyways. It gives you indication of the friction of the pads. This pad has chamfer cut on the edge to help reduce brake noise. It's got a groove in the middle to help release some gassing. The brake backing plate, I'm going to highlight here in yellow. So here's the backing plate. And then in blue, this is the friction material, right? So my rule of thumb is this. So here we are, tech tip number 6 of the night. When the friction material here is the same thickness as the backing plate or less, it's time to change those brake pads out of there, okay? Because that last little bit of friction material goes really, really fast. So it doesn't take very many miles to go from the friction material is the same thickness of the backing plate to now you're metal on metal. And so this brake pad I grabbed here tonight is a good example of this. If I hold this up to the camera, it may be a little bit hard to see. I will try to stick some light on him. You can see there that the friction material is about the same thickness. Looks like a sandwich, right? It's the same thickness as the backing plate, okay? And because I changed it when I did, it didn't ruin the rotors or anything. But if I went, another couple, 2,000-3,000 miles, I would have likely ended up going to metal on metal, metal backing plate rubbing on a metal rotor. That would quickly tear up the rotor. And now not only would I have to change the brake pads, I'd have to change the rotors. And it's not too far after you go metal on metal that now that's worn through the metal backing plate, and now it's eating up the piston, and now you got to replace the calipers, and the cost of the brake job goes up and up and up and up, right? So error on the side of caution, and change the brake pads when they're the same thickness of the backing plate. What you'll notice is that this brake pad, the groove in the center is almost worn away, that there is no groove. Look at this guy right here. You'll notice that, yeah, if it was worn down to where the friction material was the same thickness as the backing plate, pretty much that groove in the center would be gone, right? So that's another way you can gauge it. Okay. So that works pretty good. And then there's some pads that are riveted pads. Bonded pads, that's like the brake pad material is glued to the backing plate. Riveted pads, boy, you got to watch those. The pad material is really, stuck on there, but the metal rivets will dig into the rotor surface. So I don't especially like riveted pads. They tend to go metal on metal faster. Again, if you change the brake pads when they're the same thickness of the backing plates, that should give you a little bit of cushion so the rivets don't dig into the rotor surface. But I've seen more riveted pads dig into rotors than I would say bonded pads, that's for sure. Although, the argument for riveted pads is they don't lift from the backing plates. So, all right. 2 different types to attach the pads. Here's a brake pad assembly with all the anti-rattle springs and shims and clips and all this stuff. All that junk is in there to try to prevent the brakes from making noise. Okay, to try to reduce the amount of brake noise. If you take that stuff out of there, the brakes are going to make a lot more noise. They're going to have more clunking and stuff going around in there. So that stuff there is to minimize brake noise, to reduce drag of the caliper, but it does make it kind of a pain when you're putting stuff together because it wants to make everything spring apart, okay? If you're fighting a brake noise issue, tech tip number 7, replace all these things in red. It's called a brake hardware kit. If the springs and stuff are getting weak, if they've lost their tension, they won't dampen the vibrations the same, and you're going to end up with more brake noise. So good brake pads, fresh hardware, fresh rotors, those types of things will, if you do that, replace those items, that will help you solve those difficult brake noise complaints. Okay. Anti-squeal compounds. Those get smeared on the backs of the pads so that when the pad vibrates, it gives it just a little bit of cushion so it doesn't vibrate against the caliper as much and helps reduce brake noise. Don't go crazy with this stuff. If you smear it around all over and if it drips down and it gets on the friction material here, it will act as a lubricant and now your brakes won't work. So when it comes to your brake caliper slide grease, when it comes to your anti-squeal compounds, a little bit goes a long way. A little bit goes a long way on that, okay? Moving right along. Last, certainly not least, some brake pads have little wear indicators. We call them squealers. The idea is that before the brakes went metal to metal, the little wear indicator would just touch the rotor surface and make a noise. So lots of people go, oh, my brakes are making noise. And you think, oh, I need brake pads because they're used to these squealers being the cause of the noise. And then you take it apart, you look at everything and everything looks fine because the brake pads are glazed or they didn't replace the hardware like they should or didn't put a non-directional surface finish on the rotors or they just put on noisy pads. That's a possibility. What I can tell you is like by the time the squealer here touches the surface of the rotor, you are days away from metal on metal. Like this thing would make noise for like 2 days and then boom, you go metal on metal and you're eating your rotors. This thing is not very, if you can look at the graphic here, he is not very far out from that rivet touching into the surface of the rotor, right? So they didn't give you that much of a far enough in advance warning, in my opinion. Now, other cars didn't have this. Like, let's say I had a BMW, right? Like I'm on the high end, I'm luxury performance brand. They would have a little sensor that would stick in the pad in the center, and then a wire would go up to the dash. And of course, when the sensor was rubbing on the rotor, it'd turn the light on your dash. And now it was, okay, I need to replace the brake pads. And also I got to replace that sensor because it got wiped out rubbing on the rotor. So I don't know if that was a better way to go. Here's what I would say is that, every other time I change my oil, right? Like every other oil change, I'm going to be rotating my tires. And when I rotate my tires, I'm going to do a brake inspection. And if I do those things like I'm supposed to, I shouldn't be caught by surprise of, oh, my stuff's now metal to metal and I got to do brakes, and oh, I ate into those rotors, right? That should give me lots of room for identifying issues and fixing things before they become a really expensive repair. Okay. Where brake jobs turn into like $1,000–$2,000 jobs is where people neglect their brake system and they let it go metal on metal. They let all the hydraulic components fail because they never changed the brake fluid. And now you're looking at pads, rotors, calipers, a master cylinder, thousands of dollars. Okay. That's what you don't want to do. You want to be up on your brake system maintenance. Okay. If a groove's worn into the rotor, you always got to go into the groove. You want to check your rotors in multiple locations, right? 4 or 5 locations that you're looking for the thinnest area. Determine whether or not I can resurface this rotor and reuse it, or if I have to replace it. What I would say is, if you're in doubt, replace the rotor with a good quality rotor. Don't use these really, really cheap rotors. I've had problems with some import really cheap rotors being like soft metal and they just don't last. So get yourself good rotors on there. Obviously, if there's any cracking, any heat checks, discoloration, replace the rotors. Some GM vehicles had a groove cut into their rotors that was there from the factory. This is about measuring your rotors. So one thing about rotors, like a lot of times we'll use this term warped rotors, and there's some arguments out there. Are they really warped? Is it a parallelism problem? Is it a run out problem? We'll call it warped when there's really more to the story. But anyways, the idea is if the rotor is warped, it might be going down the road wiggling like this. It might be getting thicker and thinner. What those things will typically do is cause brake pedal pulsation. So anybody here, if you step on your brake pedal, do you feel your brake pedal go boop, 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 as you're stepping on it? Give me maybe a reaction. So wave your hand on the Zoom controls if you got that, because if you do got that, most likely you have warped rotors. It's probably a parallelism problem. Now, if you step on the brakes and you got like a steering wheel shimmy, like you're on the brake pedal, the steering wheel's vibrating back and forth, that's usually a run out issue. In any case, what you're probably going to have to do is either turn the rotors, or more than likely you're going to have to replace those rotors. Okay. So if you got vibration issues when you're stepping on the brake pedal, but you don't have the vibration when you're not on the brake pedal, that's a sign of what we're just going to lump into the category of warped brake rotors. And the common fix would be to replace the brake rotors. And if you're replacing the brake rotors, I bet the pads aren't in fantastic shape, and you're probably looking at rotors and pads. Okay, if you're doing that work, you should probably be flushing out your brake system as well to get some fresh fluid in there. All right, moving right along. We looked at that. Here's a drum brake there. That's got a good view of the cotter pin. Like if I forgot that cotter pin, that bolt could get undone other than that spindle, and the whole thing could fly off of there. Anyways, drum brakes use brake shoes instead of brake pads. And there's all kinds of springs and stuff in there that I got to get on or off and then back on when I'm servicing them. And that will typically require special tools. Otherwise, you're going to be armed with screwdrivers and you're going to end up extremely frustrated with a bunch of cuts and bruises. Okay, I can tell you that from experience. If you're going to do drum brakes, get yourself the proper drum brake tools, like some brake spring pliers, to do the job right. Otherwise, you're going to be just fighting yourself. Okay. Drum brakes were used on a lot of your older vehicles. They were still common up until just a few years ago to be like located on the back of the car, but not the front of the car. They do not automatically adjust, so they have to have like a self-adjusting mechanism in there. A lot of times these things don't automatically adjust properly, and you end up with a low brake pedal in the car. There's just a lot. A hardware kit, it's always a good idea to throw a hardware kit in if you're doing drum brakes, which replaces all the springs and stuff in here. There's another shot of a drum brake assembly. You can see the brake shoe. Instead of a caliper, we have a wheel cylinder that has a couple pistons in there, self-adjusting mechanism. Brake shoes, there's a lot more surface material here. So the brake shoe is not as thick as a brake pad because it's got so much more contact area or surface area to it. Here's another shot of a drum brake. This particular one would be called a duo servo drum brake. And it's the bottom of it can move back and forth. My tip for you guys, this would be tech tip number 8, is let's see, number 8, don't work on drum brakes until you're ready. Like, I wouldn't recommend messing with them until you're actually in brakes class. And then to follow that, if you're going to do drum brakes, you only do one side at a time. So you can use the other side as an example to look at, because I guarantee you're going to take all this stuff off of there and then you're going to be like, oh, I forget how it goes, right? Now, these days we have cell phones, right? We could take a picture of this with our phone and that would be a great idea. But sometimes the picture just doesn't tell the whole story. And so by doing one side at a time, you can look at the brake on the other side of the vehicle and use that as an example to figure out how to reassemble the brake that you just took apart, okay? Again, get those special tools if you're gonna service these things. All right. There's a brake drum. Now, rotors can get worn too thin, so they have a minimum thickness. Drums can get worn too large, so they have a maximum diameter rating. It's a little different setup. There's your wheel cylinder on the inside. These are real common. If you don't change your brake fluid, these fail and they start leaking brake fluid all over. So here's one that has been serviced and cleaned up and new brake shoes have been installed. And you can see it also has new brake hardware here. The springs and stuff look fresh. This guy's looking pretty good. Wheel cylinder is here at the top. This would be an example of a leading trailing drum brake design. Now, you might think, well, okay, if drum brakes are so terrible, why do they still use them? Drum brakes are mechanical in nature and they work really good with your parking brake. So what you can just barely make out from this image is here is a cable coming back through here, and it moves this parking brake lever, which forces pressure on this parking brake strut. And essentially it works good. It makes a good parking brake because it's all mechanical in there. Okay. When I have to do a parking brake with my disc brakes, I either have to have a mini drum on the inside or I got to have an overcomplicated caliper design. So one thing I will say about drum brakes is, hey, they work good as a parking brake, and they are mechanical. They technically, you have a lot of leverage here with this big old brake shoe. So a drum brake really is a more powerful brake. That's why you still see them used on like big trucks and stuff. It works well with air brakes and everything else. But boy, they are a lot more complicated to service. They are a pain in the necks. They don't auto adjust. They have to have some type of star adjuster in there to get them to auto adjust. This thing usually stops working and then the brakes get all out of adjustment. But you know what? It's just one more thing for us to fix. So is what it is. We talked a little bit about parking brakes already. A lot of people will call these emergency brakes. They're not really made. I mean, in an emergency, you do whatever you got to do, right? So you might use it in an emergency. That's where it gets the name, but it's not made. It's not like it's more powerful. It's not like it's bigger or better or anything. It's actually a much less efficient brake. It's really built to hold the car still while it's parked, right? So sometimes you'll find that a car has a parking brake that, stops really quickly. And other times you'll find you put the parking brake on, it barely keeps the car from moving because it's really made for parking. It's not necessarily made for emergencies. There's an example of that parking brake. And again, you step on a pedal or you might pull a handle, and essentially what you're doing then is pulling on a cable, which then has to run the length of the vehicle and apply usually the rear brakes at the other end. Okay, and speaking about brakes, here's the parking brake equalizer. So it's pulling one cable. It has to go to two brakes. So it uses this equalizer to spread that braking force out. And where the equalizer comes together, it's usually somewhere underneath the car, is where you can do a parking brake cable adjustment. But usually when your parking brake's really low, it means your rear shoes are worn, not that the parking brake cable needs to be adjusted. So tech tip number 9. You have a parking brake that doesn't work, check the adjustment of your rear drum brakes. They are probably out of adjustment. It's probably not the parking brake cable that needs to be adjusted. It's the brake shoes themselves that need to be moved out, meaning that you have to move out this star adjuster right here is not adjusting correctly. 9 times out of 10, that is what the problem is. Okay. So remember that when you're braking, the vehicle's weight transfers to the front. So it's not like this image of this guy right here where he's lifted up the front of the car. Really what happens is the car's weight transfers to the front. In fact, when we're on the racetrack, we do that a lot. You know, what are race car drivers? We're weight managers is what we are. We're constantly managing the weight of the vehicle on all 4 corners. If I want the car to have more front grip, I'm going to give a little brake because I know that's going to transfer weight to the front of the car. Okay. But where am I going with this? Well, when you step on the brakes, and if you step on the brakes hard, most of the braking is going to be done with your front brakes. Okay. So that's why we have here that 60 to 80% of the total braking force required to stop the vehicle is on, you guessed it, the front brakes. So tech tip number 10 for tonight is that, hey, your front brakes are going to, on most cars, your front brakes are going to wear out before your rear brakes. Okay. Why? Because they do most of the stopping. Okay. So you're probably going to go through 2, maybe 3 sets of front brake pads before you'll have to change the rear brake pads. And that's just how it is. Okay. Now, does anybody know maybe, of some cars where maybe the front brakes would not wear out as fast as the rear brakes? There's always exclusions to the rules. So I said, hey, tech tip number 10 is the front brake pads wear out first on most cars, but there's always exceptions to the rule. Does anybody know of a car that is that exception to the rule where it's maybe wearing out the rear brakes before it's wearing out the front brakes? Does anybody have an idea of what car would be doing that? All right. Well, I won't keep you guys in suspense because you're probably sleeping anyways. What it is your hybrids and your electric vehicles and stuff. So you take a car like a Prius, and what was weird about those is if the person who drove it was a really good, smooth driver, and so they weren't slamming on the brakes, they were stopping gently, that car would do a lot of regenerative braking. So what brakes on that car do the regen? The front wheels do the regen. So that means the front brake pads don't have to work that much. And so you'd end up wearing the brakes a lot more evenly. In some cases, even the rear brakes would wear out before the front brakes because of all the regen happening on the front wheels. So there's always exceptions to the rules. But if you take your average pickup truck or sports car or family minivan or SUV, it's going to wear out the front brakes first. Okay. So that was your 10th tech tip of the night, which is a good way to finish out our class for the evening. Okay. So I'll switch our screen share back to the internet, and I want to give you guys a chance to ask any questions. Man, I loaded up CDX. I thought I would be using some stuff on CDX there. Didn't even get to it tonight. Again, this is all the stuff I have for you on brakes. And I even put together one of the videos myself, which should have just, launched now. Let's see if it's working, where we're doing a front brake job on a NA Miata. I have several videos that get into brake theory, all kinds of stuff. You guys know the drill. There we go. We're putting some hot brake pads on there. Even measuring the thickness of the rotors. I don't show you the disassembly. I actually shot this video as I was doing a complete suspension rebuild on this car. You see that there's some coilovers and stuff I put on that car. So I don't do the disassembly, but I do a complete assembly and lots of tech tips, of course, along the way. Putting on some Hawk HP Plus pads, which turned out they're great for taking to the track and doing autocross with. Honestly, for the street, they're a little too aggressive. If I have my street tires on the car, man, I can lock up the brakes pretty easy by getting on it hard. So anyways, so that video's there for you. Lots of good resources. I know you guys are likely going to be playing with the brakes on your cars, and I wanted to give you some good information to do that correctly and do it safely. Okay. So if you guys don't have any more questions for me tonight, I will let you go. I do want to say that, hey, your grades are pretty much up to date, other than I haven't added all your extra credit bonus points for attending our Zoom sessions. I'll get that going here in the next few weeks. Keep working on your worksheets and getting those submitted. I will get the assignment dates dialed in for you, because we saw a few of those were off tonight. Next week, we'll be preparing for the midterm exam. We'll be doing some review for that together and just kind of doing some questions and answers and getting you guys ready for that. And then, you know, like I always say, keep learning, keep having fun. If there's no more questions for me, I'll let you go. I'll give you one more chance. Anybody have any burning questions? Anything they want to bring up? Let me check the chat here. No, looks like everybody's okay. All right. Well, you guys have a great week. Try to stay dry, and we'll catch you next time. Goodbye, everybody.